Hemostasis, stopping the bleeding. What is the very first thing that's going to happen?
Vasoconstriction around the area.
Vascular spasms, vasoconstriction. Slow down the blood flow. That's going to keep going, but then something else is going to happen. Platelet plug. That's going to be the next in the process. Number 3 that we're going to get on here is the actual formation of the blood clot. Now there's a lot more detail than we're going to go into here. And you said, yay, right? Okay. We're going to talk about some things, but really trying to give you the overview of what's happening with coagulation. In our plasma, we have these circulating proteins, right? Some of those proteins are our inactive clotting factors, and there's a whole cascade of them. And one very important one at the very end of this cascade that makes these really, really sticky fibers is fibrin. Remember, it starts as what? What's the inactive form of fibrin? Fibrinogen. And this whole cascade from these factors beginning with an injury, some platelets activate these things. There's a whole domino effect, and one of the last dominoes to fall is fibrinogen being converted into fibrin. And that's going to make this whole sticky meshwork that you see. And what's going to stick in fibrin? Everything. Red blood cells, platelets, white blood cells, other fibrin. It's just a sticky mess. That's the clot that's going to stop the bleeding. So let's just talk about the cascade just a little bit. We've got to have this entire series of proteins that are in fact enzymes. But again, before you have an injury, they're inactive. And typically they do have some big fancy names, but they're also going to have Roman numerals. And so inherently, depending on how this pathway starts, and there are 2 ways it can start, you're going to have one factor, and I think factor 12 begins it in one pathway. Factor 12 is activated. It is an enzyme that's going to activate the next factor, factor 11. And then whoever made this thing up, I don't know, but you got to skip 10 and then go to, so anyway, you see one gets activated into an enzyme that activates the next one that's an enzyme that activates the next one. Finally, we end up with this network of fibrin. So clotting factors, you got to have these clotting factors, they have to be activated. But to activate them, you need more than just other clotting factors. You're also going to need vitamin K. Maybe that's coming out of left field and you never saw vitamin K coming. But vitamin K is important in binding to a particular enzyme that actually reduces vitamin K to a form that can then allow certain amino acids in some of these clotting factors to carboxylate. Basically, you take carbon dioxide and you convert that into a COO with a negative charge on that amino acid. So you're basically causing this amino acid that wasn't charged to now be a negative charge. I'm spending a little bit of time on that because the charge is important here. Because this clotting factor now that has this carboxylated glutamic acid, it has to bind calcium. What charge does calcium have? Positive. That's what that negative carboxyl on those clotting factors with those glutamic acids is there for, to bind the calcium. You remember last semester? What ion did you have to use to cause your neurotransmitters to be released at the synapse? Calcium. What ion did you have to have that bound to troponin that caused it to slide tropomyosin out of the way? Calcium. What does calcium not do? And here we've got calcium again. Calcium is in your bones. It does everything. But you've got to have calcium for the clotting cascade. You've got to have the factors. You've got to have vitamin K in its active form. And you've got to have calcium. How many of you have ever given blood? Have you ever noticed in that collection bag, there's some fluid in there? You ever wondered what that was? It's sodium citrate. What is it there for? It's an anticoagulant. So what happens when your blood, you've got it all stirred up now. You're taking it out of your body. You're putting it in this bag. It's shaking all over the place. That could activate inadvertently the clotting cascade. And what sodium citrate does is when sodium citrate encounters calcium, guess what happens? Phew, calcium citrate. Now calcium's busy in this molecule with citrate. It can't bind to the clotting factors. So you can't start the clotting cascade. You can use, there's another material called EDTA, ethylene diamine tetraacetic acid. You're not going to have to spell that. It is a chelating agent. A chelating agent will basically soak up some of these minerals. And the thing that it associates up more are divalent ions, magnesium, and what else? Calcium. You don't use EDTA very much in the clinics, but you will see citrate all over the place. You're also going to encounter patients that are on Coumadin. Have you ever heard of Coumadin?
Yeah, blood thinner.
Coumadin is a blood thinner. It prevents clotting to a degree. Coumadin works by preventing the activation of vitamin K. If you can't activate the vitamin K, you can't convert those glutamic acids into a negatively charged carboxyl group. They will never bind calcium, so it's as if calcium's not even there. Now, if a patient is on Coumadin and they're scheduled for surgery, they have to come off of that before surgery because after surgery, you don't want them bleeding out, right? That's bad. The other thing that you have to watch out for with your patients with Coumadin is their diet. Now, they will check your ability of the blood to clot in those patients and give you a reading, a clotting number reading. And if your blood is clotting too much, your patient will be told, take another half a dose of your Coumadin. But if your blood is too thin, maybe a little bit too thin, will they tell the patient to take less of the Coumadin? No. What will they tell the patient to go home and eat for dinner? What's rich in vitamin K?
Carrots.
Really?
No.
No.
I Googled it.
There's something more common.
Bananas?
We like it here in the South. Bananas are potassium. Huh? Here, we like them here in the South. Now,
Greens.
I'm not going to eat them without cornbread. Greens.
Oh,
Your collard greens, your turnip greens, your mustard greens.
turnip green.
I'm seeing people like turn up their nose. Are you kidding me?
Oh, I love it.
What? Then eat greens with hot sauce and cornbread?
Yes. Oh,
The texture.
what?
So, if you have a patient on Coumadin, please make sure they understand that their diet can affect the ability of their blood to clot. My dad was on Coumadin for years and years and years, and if his blood was a little too thin, they would send him home, say, don't change your medication, just eat some greens. And when he would come back, his blood would be perfect. So vitamin K, while you're on Coumadin, can affect the ability of the Coumadin to actually work. You know where Coumadin came from? Originally identified from leeches. Because when leeches penetrate the body, they're going to drink the blood. What do they not want the blood to do? Coagulate. Then they got to form another hole, right? Defeats the purpose. So that's where this came from, is coumarin from the leeches. But there's also another pharmaceutical agent that is much more insidious that is developed from coumarin. It's called warfarin. Where do you find warfarin? Well, Coumadin is a form of that, but warfarin you're going to see on boxes of rat poison.
Really?
Really. Because the rats eat the pellets that I guess taste good or smell good to rats, and they eat so much of it, they bleed out internally because their blood is so thin. Isn't that lovely?
Crazy.
So that's why if you have a rat problem, but you have small animals, don't just put out rat poison. Because if your small animals eat it, they will be in big trouble too. Hang on just a second.
Okay, so you said about the blood thinners. Whenever we were talking about, remember you talking about the syrup blood?
Yes, polycythemia, you have too many red blood cells.
Do they use blood thinners to thin out polycythemia?
So what is the treatment for people that have too many red blood cells?
Well, just blood, like just
Bloodletting, you go get blood. Yeah,
Oh, that's it?
that's it.
Oh, okay.
You have to go in regularly and have your blood drawn, and what are they checking every time you come in? Your what?
Red blood count?
Not blood pressure, we're talking about blood cells now.
Your red blood
Your
cells?
iron or hemoglobin, kind of with the iron. There's the H word. Hematocrit. They're going to check when they stick your finger first thing before giving blood, they're checking your hematocrit. If you're anemic, they're not going to take your blood. If you're polycythemic, they're probably going to be okay with taking it and say, hey, can we get more? No, I'm kidding. They'll only do 1 unit at a time. But that's how they treat polycythemia.
Okay, could a body like overproduce vitamin K and that cause more clotting? in the
Your
blood?
body doesn't really, you talking about activate it? Because your body doesn't really
that's
produce
correct,
it. You get in your diet. There possibly is a condition. I don't know that exists. I would think it's rare. Because if there's a disease where you activate too much vitamin K, that would make your blood really, really clot, which would probably lead to like some thrombi and heart attacks, strokes in the brain. What's the one in the lungs? Yeah, drawing a blank on what it's called though. Embolism, pulmonary embolism. Yeah.
When you sustain an injury, what's the first thing that gets released that starts the cascade of enzymes?
So really the first thing that is going to activate the clotting cascade are going to be some factors from platelets.
Okay.
Remember, vascular spasms, platelets, then the clotting cascade.
Okay.
But it's going to depend on the injury too, because there are two ways that you can activate. It's like the letter Y. And so there are two ways you can activate the clotting cascade, and they both impinge on factor 10, which is, I guess, why they go from 12, 11, 9, 8. They skip 10 because somebody stuck it down there first. I don't know. And so with this pathway called the intrinsic pathway, this is going to be, it's going to take a little while to get going. 3 to 6 minutes, and again, that's going to be platelet plug activation. You're also going to get some secretions from the damaged endothelial cells. So it takes a little while for that to get going. I refer to the intrinsic pathway as a paper cut. You know the paper cuts that hurt like everything. People get shot with a gun and they don't hurt as much as a paper cut. I don't know why. But what's the first thing you do when you get a paper cut? Anybody else?
Yeah.
My paper cut goes right in my mouth. I think it is instinctive because guess what's in your saliva? Anticoagulating agents. And lysozyme, an enzyme that kills bacteria. And then just this comforting, I guess. I don't know. But when you get a cut, I stick it in my mouth and then immediately I'm applying pressure, right? Apply pressure. Okay, how many of you are like me? You get a cut, a paper cut? Oh man. Dang, still bleeding. Okay. Man, I got to go. I got a class. Amani's going to give me trouble today. Oh, shoot, it's still. Anybody else like that? You're so impatient. You keep looking and every time you look, it's still bleeding. It's not still bleeding, it started again because the clot hadn't completely formed, and when you look, it just blows it out and you reset the clock. So apply pressure and do it for several minutes, and don't keep checking and checking. So the intrinsic pathway, intrinsic refers to factors that are in the blood already, our inactivated clotting proteins, versus our extrinsic pathway, says triggered by damage outside of the vessel. It's going to start in 15 seconds. The extrinsic pathway is not a paper cut. I don't like gray, you know, something that's a gray area. I like big differences. So I call the extrinsic pathway a paper cut. You know what I call, the intrinsic. The extrinsic pathway, I call shark victim. You seen some of these shark attack victims? Lost legs, lost arms, big chunks taken out of their calves, major damage. And with the extrinsic pathway, you have factors that are inside the cell, that when the cells are damaged, they get released, and they take a much shorter path to factor 10. See, here we got 12, we got 11, we got 9, 8. Here, we basically have this release from the cell, poof, we start it. Because if you have major trauma, major hemorrhage, you've got to try to stop it as fast as you can. A paper cut, you're not going to bleed out from a paper cut probably, unless you're really amped up on Coumadin, and you're just going to let it go. Hang on.
What did you say intrinsic refers to again? Is something about the inactivated proteins?
Extrinsic, the factors that are going to start this clot here are inside the cell.
Okay.
All these factors in the intrinsic are out in the plasma already as inactivated.
So because of, like, extrinsic is more of like life-saving, is it activated by the sympathetic nervous system, would you say?
Oh no, this is when you damage the cells and those factors that were in the cells
Oh,
are
so
there.
It's just based on
Bam.
the location of the factors
Correct.
in the cells.
Yep.
This is just because I'm curious, but like internal bleeding, like in the body, like trauma, of anything like that, does it like clot and stuff?
You're going to clot wherever you have these activated proteins. So even internally, you're trying to form clots, but a lot of times when you're bleeding internally, you're going to have a larger injured area. Because to damage internally, you've had some major, major trauma. Yeah. One internal injury like that, and you hear about it on the news a lot. The actor, was it John Ritter? Played on The Rules for Dating My Daughter. He was on the old Three's Company back in the day. He was on set of the show and he kept passing out. Well, they finally called the EMTs, loaded him in an ambulance. He basically had what's called an aortic dissection. Your aorta burst open. And he kept fainting because as all this blood was filling up his thoracic cavity, his blood pressure was dropping and he kept passing out. He was dead on arrival at the hospital. How are you going to stop that kind of bleeding? It's just too much, too fast. Yeah.
They can do a cardiac test lab, get surgery done.
You get there fast enough. But you see, he's just passing out. I think it's just hereditary.
Really? That's scary.
Yeah, I think it's hereditary. Yeah. All right, so there are two ways to start them. Paper cut from our activated plasma proteins, those clotting factors, versus the extrinsic, the major damage that is released from damaged cells in the area. They're both going to impinge on that factor 10, that's the X factor, and you see that's going to activate these others. It's going to activate an enzyme called thrombin. Thrombin, when it's activated, clips the O-gen off of fibrinogen to make fibrin. There are other drugs that you can use. Heparin, I believe, is an anticoagulant that affects antithrombin. But again, heparin's not used often because it doesn't clear the system very quickly. So the business end of both of these is to activate fibrin and form the clot. Again, small cuts, takes a little longer. Major damage begins right away. And depending on how major that damage is, you may be able to be helped and you may not. So somebody asked about sympathetic. I forget who that was. Well, we do have some sympathetic responses. While those things are going on, you realize this is an emergency situation. If you're a major trauma, it's not just going to be one thing trying to save your life and your body. It's a lot of different things. And so when you look at what's going over here, when you lose 10% of your blood volume, that's half a liter, right? 5 liters on average. If you lose half a liter of blood, your body goes into panic survival mode. And this is where sympathetic occurs, right? Fight or flight. Would you not agree if you're bleeding out, you're panicked? You're stressed, even more than my quizzes, right? Whatever. So your heart rate's going to increase. Your heart's going to beat faster. You're going to constrict a lot of your major vessels. And I dare say some of those vessels going to your skin, going to your extremities, are probably going to close off. Because if you bleed out, it doesn't matter if you have fingers or toes. This is survival mode. This is not optimal homeostasis, right? This is survival mode. So that's sympathetic division. You've got to do all these things to maintain blood pressure as your blood volume is decreasing rapidly.
Would that be like going into shock?
You will be going into shock, yes. You will absolutely be going into shock. And as your blood pressure drops, what's the one thing that's regulated by your bloodstream and blood flow? Typically, when you have someone in shock, what do they always want to do to someone in shock? A blanket. Because you're losing blood, which means you're losing heat, internal temperature. So that's all going to be a factor in this as well. So your blood, it's not going to your toes, it's not going to your fingers. We're going to heart, we're going to brain, we're going to lungs. We're not even worried about going to too many of the other muscles at this point, because we're just trying to survive in a bad situation.
That would be the same for like hypothermia, right? That's why you get it on your toes and your fingers.
Well, yeah, frostbite's going to occur because you can't freeze your core. You've got to keep your body temperature here and your brain first to the sacrifice of others. Now, once you've lost 40% of your blood, notice it's not even 50%, it's only 40%. Losing 40% of your blood is really called bleeding out. If you've lost that much blood and you don't get something immediately, then it's probably game over. Yeah, I don't know that it's recoverable from that. So that's why tourniquets, somebody said tourniquets a while ago. Tourniquets may not be the greatest thing in the world. You may lose a limb, but lose a limb versus lose your life. Again, this is an emergency.
I'm guessing that just helps the vasoconstriction.
Oh, it just if you're injured in your leg, like in a lot of the wars, Civil War especially, if you've got an injury and you've got some big, huge vessels under a lot of pressure, you just got to shut them off. So it's constriction of the blood vessels. It's just constricting everything. And tourniquets, I don't think they feel good because they're tight. Tight. But again, we're survival mode here.
There's a lot of EMS protocols before you want to put on a tourniquet.
Yeah.
That's one of the last ones.
Exactly, because you put it on and you might do more damage than is necessary. Okay, have we heard of hemophilia? What is hemophilia? A bleeding disorder. And it's possible that one or more of your clotting factors are mutated, and therefore you can't clot. And these are inheritable. And so as we look at hemophilia inheritance, The most common, which is hemophilia A and B, are both inherited as X-linked recessive. Do we understand what that means? If it is X, let me add a word, X chromosome linked, what does that mean? That means the gene that is affected is on your X chromosome. How many do you have, ladies?
2.
Guys? You got 1. Now, maybe you haven't covered, I think heredity is going to be at the end of this chapter, but did you get some genetics in high school biology? About the green peas and the tall plants and la la la. So you understand what recessive means versus dominant. Genotype is what your genes are. Phenotype is what it looks like. So if this is a recessive condition, females, how many bad genes do you have to have before you're a hemophiliac? 2. How many do the guys have to have? 1. So generally in the population, men are at higher risk of hemophilia because they just need 1. So let's kind of follow this pattern. This is typically what you see. If you see a dad that is not a hemophiliac, is he going to have a good gene or a bad gene? Good gene. He's got to have the good gene. If he had the bad gene, what would he have? Hemophilia. Now we got mom, doesn't have hemophilia, but look at that. She's got one of her X chromosomes has the mutation. So as we look at the offspring, look at the guys. We got 2 boys, no hemophilia, with hemophilia. The boys have a 50-50 shot. Because they're either going to get this X chromosome from mom or that one. Are they going to get are the boys going to get an X chromosome from dad? What are they getting from dad? They're boys, they got to get the Y from dad. So it's a 50-50 shot from mom. But look, the females are 50-50 not of having hemophilia, right? None of the female offspring have hemophilia because they're getting one good X from the dad. You know that they had to get that from dad, right? Because if they got the Y from dad, they would be a boy. Now, let's go a little bit further here. Dad's a hemophiliac. Mom is not even a carrier. Are any of the girls going to have hemophilia? No. But if dad's a hemophiliac, won't all the boys be hemophiliac? No. I tried to trick you. Y'all know my trick. Because they're only going to get that one bad X from dad, but look, mom's not even a carrier. So the boys are going to be just fine. But notice all of the girls are going to be carriers. So that means their offspring might be at risk. All right, one more. Dad's got hemophilia, mom's a carrier. We're going to have more of our offspring, our children are either going to have hemophilia, and here we've got a son and a daughter that both have hemophilia. They got the bad X from mom, certainly the bad X from dad, and then we got a carrier. We've got this one son over here, lucky son of a gun right here. He got the good Y from dad, and he got the good X from mom. Sometimes genetics is just a lottery. But that's why sometimes if you have these mutations, genetic counseling is important. Thrombocytopenia, deficiency in your platelet count. Now, you can understand if you don't have enough platelets, you're going to have a bleeding problem. All right? So, you can have infections. There's some drugs that can interfere with the clotting cascade. People that have heart arrhythmias. We're going to talk about arrhythmias a little bit. With a heart arrhythmia, your blood can kind of have turbulence. It's not smooth flow, and that turbulence can make platelets angry. And if they get angry, they get sticky. And so with some of these conditions like atrial fibrillation, that's not life-threatening. Typically, what do they prescribe over the counter to individuals that have some of these not really severe arrhythmias? Baby aspirin.
What?
Baby aspirin, because aspirin is in low doses an anticoagulant, and it just prevents the platelet formation and activation, and thus prevents the clotting cascade. So there are a lot of things that do that.